Hi, welcome to this lecture on Spark Actions. This is your instructor Kumaran here. Spark Actions provides a way by which you can execute a number of operations on Spark that produces various results. So a Spark acts upon an RDD and produces a result which is not an RDD. Typically these results may be like one element, a one number or one element or something like that, which is more a summary of the RDD than anything else. It uses lazy evaluation, so Spark does not act upon an RDD unless it sees an action put on it. So if a Spark RDD is created, some transformations are done on that RDD, those are not executed unless an action is executed finally, which is when Spark goes and executes the remainder of the earlier actions. Simple actions that you would typically have in Spark are the actions like collect. So collect basically will print the contents of the RDD to your standard output. It just returns all elements of an array. You can either use collect to print to the standard output, or you can use it to put it on another RDD or put it on another collection or something like that. Count is a action that can be used to simply count the number of elements in the RDD. That's a very simple operation. First returns the first element in the RDD, and take n returns the first n element. So these are some of the simple actions that are available as a part of the action add RDD set. There are also a lot of other actions available. We will be focusing mostly on the key ones that are available in Spark in this lecture. So one of the most important actions in Spark is the reduce action. Reduce performs some kind of operation that is across all elements in the RDD, like sum, count, etc. So reduce is something very similar to the reduce function in the MapReduce in the Hadoop world. So it performs an operation across each element in the RDD and provides a summary like a sum or a count or any other custom computation you want to be doing on that particular RDD. So the way reduce works, this is a little difficult to understand. So I ask you to kind of pay a lot of attention to this one and kind of go over and over and again before you get the full picture of how reduce works. So reduce has an operator, it takes a function that takes two values. So there is a function that takes two input values and produces one output value, and that is the function that is provided for the reduce operation. And this function recursively goes through every element in the RDD and performs the entire operation. So for example, let us say there is an input RDD with elements A, B, C, D, and E. And there is a function func of x comma y. There is a function that takes parameter x comma y, acts upon it, and produces a single result or a single element as its result. So the way it would be called is that the function will be called on the first two elements in the RDD, a comma b. So func of a comma b will be called, and whatever result is produced by this function then will be used again to call the same function with that result and the next element in the RDD, and that result will be again be taken to call the next element and so on. This becomes like a recursive call where it will traverse the entire input RDD. It starts from the first two elements, then keeps moving on to third, fourth, fifth until the end of the RDD, and the execution of this entire function is completed, and then the result is produced. Actions are not typically partitioned. They don't work on partitions because it is across all RDDs. So they are kind of performed across all the partitioned RDDs. But the way, as you can see, the operation is performed here helps in such a way that it goes and performs first in one node. Let us say the elements are split between two nodes, like A, B, and C are available in node 1 on the cluster, and D and E are available in the second node in the cluster. So first function call of a comma b happens on the first cluster, and A, B, C happens again in the first cluster. Then it moves to the second cluster and so on. So it's kind of executed in serial fashion, not like in a parallel fashion like a map would work. An example, let's say here is that there is an array vals. This is an RDD actually of a simple numbers. There are a set of 5 numbers in this RDD, and you have a function, a simple function called sum x comma y, which returns x plus y. It's a very simple function that takes 2 parameters x and y and returns x plus y. And how this reduce would work? It will start with calling this function sum for the first 2 elements in the RDD, sum 3 comma 5, which will be 8, and then result 8 is again used to call the sum again, sum of 8 comma 2, that will return 10, and then again you call sum 10 comma 4, that will return 14, and this way it keeps adding up the entire RDD to return this result of 15. So this is how reduce works. Reduce is very similar to the map reduce you find in Hadoop. Now comes another more complicated, a very complicated operation action in RDD called aggregate. Now aggregate is a very powerful thing, a very powerful action that can do a lot of stuff, but you also need to spend some time understanding how this aggregate works, which is a little twisty to understand. So please pay attention. What is aggregate? Aggregate helps you to perform parallel computations across partitions, and then you can combine them. So you have data that is partitioned across multiple cluster nodes. You can first perform individual actions on each of these partitions, and then you can then aggregate them together. So it has two operations that it can perform. There is a sequence operation. A sequence operation is performed individually on each partition. So the sequence operation is performed individually on each partition, means it can actually happen in parallel across all partitions, right? So sequence operations happen in parallel on each partition in parallel. And then there is a final combine operation which combines the results of the individual sequence operations across partitions. It can be then used, the combine operation can actually combine the results and produce a global result. So there is sequence operation first, and there is a combine operation second. And then added to that complexity is another thing, that it can actually do multiple computations at the same time, which is it can perform multiple sequence operations and multiple combine operations at the same time. So that's really giving you a lot of parallel processing power. But yeah, it is a little difficult to understand and understand how this one works. So let us take, for example, this RDD, which is again 35474. is an RDD. Okay, so how does this one work? The sequence operation you're giving here is again kind of a function which takes a lambda x comma y. So it takes as input 2 variables x comma y. And what does it result? It returns a collection. The first collection says x of 0 plus y. The second one says x of 1 plus y. What this is doing is actually that it is returning the sum of the 2 inputs as well as the product of the 2 inputs. We just come to the 0 and 1 just in a minute. So it just takes x comma y, it produces both the sum and the product. Now how does the combine operation work? Combine operation combines the results of the various sequence operations that happens. So combine operation typically also does exactly the same thing, which is it takes x comma y and it returns x of 0 plus y of 0, x of 1 into y of 1. Basically it is aggregating the same old thing, which is this is the addition of the data across partitions. This is the multiplication of data across partitions. And whenever you're collect the aggregate function, so call data.aggregate on this RDD, what it is going to do is you also pass what is called as the starting initial identity operator. Now what you do with the identity operator is you tell the aggregate function how many values you are going to compute as a part of this one. So you say 0 comma 1. So first thing it tells the aggregate is I'm actually be computing 2 values there. And then I'm going to be passing the identity value for both these operations. What is an identity value? An identity value is one where you use this and apply a function on this plus something else. It is going to give you only the something else. In the case of addition, the identity value is always 0. In the case of multiplication, identity value is always 1. So either one of them is going to be true. Basically, you apply that, it is not going to change your end results. So what is going to happen here? and let's look at how the sequence operation will happen. The sequence operation is going to start with x of 0 plus y. So the x of 0 here in the case of sequence operation is this first 0 in the front. So x of 0 is nothing but this first 0 in the front, and y will be the first element in the RD. X of 0 is 0, y will be 3. So x of 0 plus y will be 0 plus 3, which will be 3. Similarly, x of 1 plus y, in the case of x of 1, this is the x array and the 1 is x of 1. X of 1 plus the yth value, so x of 1 plus y, which will be 3 into 1, which will be 1. So 3 plus 0 will be 1, 3 into 1 will be 1. So that's why it is identity, because the first operation returns nothing but the first element. Now these results are then taken and then applied recursively with the second element, very similar to how your reduce operation works. So you have 3 and 3 here. Next, x of 0 becomes 3, x of 1 becomes 3. So 3 plus the next element 5 will give you 8. 3 into the next element 5 will give you 15. So the next one will be 8, 15, and this recursive operation will continue. Now once the sequence operation is completed in each of the partitions, you will have multiple such sets, multiple such sets, and then the combine operation will take each of these already accumulated data per partition and combines them totally. So in this case, what happens is this is work exactly like your reduce operation. So x of 0 plus y of 0 is basically, in this case, the x and y will be the results returned by the individual partitions. If you have two partitions, x will be the first partition result, y will be the second partition result, and then all you're doing is adding the results of individual partitions and making up the combined result. Similarly, in x of 1 into y of 1, you're multiplying the values and getting the combined result. So for example, here you have a part on the RDD and it has two partitions. The first partition is in one node, second partition is another node. The sequence operation will produce first 12, 60 and 11, 28. Because the sequence operation will first apply here on 354, and that will produce both the sum as well as the product of each of these numbers as separate collections here. And then the combine operation is going to take these two and apply the combine operator and then produce the final end result. The advantage here of this as compared to the reduce operation, I mean, this is basically doing the same thing that the reduce operation would do. You have to write two reduce operations to do the sum, one to do the sum and one to do the multiplication. But the advantage of using aggregate here is that you're doing both sum and the product at the same time. And second, by using the sequence operator, you're actually trying to improve some parallelism in terms of what operations you can do in parallel across your various partitions and then combine overall. So if you have 4 partitions, the final serial operation that you do will be just adding 4 numbers, as opposed to if that particular RDD had like 100 numbers, you would be adding 100 as a serial operation. Rather, you split the 100 into 25 each, do the computation in parallel across 4 partitions, and only finally use the serial operation to combine it. So that is the advantage of using aggregate. Pretty complex, let us go through it a few times to kind of understand how this one works. It's a little complex to understand. Pair RDD actions, we saw what kind of pair RDD transformations are available on key value pair RDDs. There are actions that are available on pair RDDs like count by key. So in this case, what it does is for every key, it gives you a count of the number of values that are there in that key. You can do group by key. You can perform an aggregation like sum or average of the values by key. You can do reduce by key, in which case the reduce operation is run for every key. So for every key, reduce operation is run once, and the result is also produced by key. By key, you can get a value out of the reduce operation. You can do aggregate by key. So the reduce by key and aggregate by key works exactly the same way we saw for the normal reduce and aggregate, except that it is done on a key by key basis. So reduce and aggregate by default produce one result. In this case, there is going to be one result per key. So this is how the various actions, the key actions in Spark work. There are a few more actions in there. If you go to the Spark website on the APA docs, you will see more of them. But these are the ones that you are going to be using mainly. The more complex ones and the more important ones is what we discussed as a part of this lecture. I hope this has been pretty helpful to you. You would see examples of how to use these transformations and actions in the code example that is going to be in the following lectures. Thank you.